Hello, everyone. In today's video, I'm going to be discussing the mathematical concept of infinity. First, I need to mention something. Today's topic: numbers. First of all, we need to establish something. Infinity is not a number. It's the concept of forever, or something that has no end, or boundaries. But before we dive into the reality of infinity, let's talk about the finite numbers. Let's take an example. 1,000,000. 1,000,000 is a ginormous number. But it's finite, meaning that it has limits. Even numbers like 1,000,000,000,000, which is a 1 followed by 12 zeros. But keep in mind, even 1,000,000,000,000 is finite. Okay, these are all numbers that you are familiar with. But let's get bigger. Numbers like 1 septentillion, which is huge. In fact, this is where numbers start to get incomprehensive. Septentillion is a 1 followed by 54 zeros. There is no physical way to describe the actual size of this number. But even this number is finite. Then there's 1 vigintillion, which is a 1 followed by 63 zeros. And then finally, we reach the incomprehensible number called Google. Now wait, I know what you're thinking. Isn't Google the name of the internet company? Yes, it is, but it was actually named after the ridiculously huge number Google. Anyways, 1 Google is 1 followed by 100 zeros. That is insane. I mean, a 1 followed by 100 zeros. That's crazy. But even with these huge numbers, they're still finite. Okay, we're not really jumping that much, but here's where numbers start to get really big. Let's take this number. 1 centillion. I can't even describe of just how enormous this number is. This monster number is 1 followed by 303 zeros. Much, much, much larger than the Google. The next number is so mind-boggling gigantic and extremely large that there is not enough atoms in existence to fully write it down. This number is called Googleplex. This number is 10 to the power of 10 to the power of 100, or 1 followed by a Google zeros. The size and enormity of this number is absolutely colossal and mind-breaking. But here's something even worse. Numbers go on for forever, meaning that there is no end to numbers. You can always have a larger number. There's more mind-boggling incomprehensible numbers, larger than Googleplex, such as Graham's number, which is so large that if you were to fully comprehend its size, it would break your brain. Then there's enormous tree 3, which is much larger than Graham's number. There are more numbers that are much larger than tree 3, such as Loader's number, Rao's number, and fish number 7. Just to give you an idea of how gigantic these numbers are, they are so big you cannot calculate them. But just remember, these are far behind infinity. Another thing to keep in mind is that all these gigantic mind-boggling numbers I'm telling you about are finite, meaning that even though these numbers are so colossal that no calculator could ever comprehend or measure their size, they eventually have limits. But infinity has no end whatsoever. There's absolutely no way to measure infinity's size. Now here is a paradox about infinity that I would like to talk about. It's called the Hilbert Hotel paradox. This paradox only gives you a scribble of how large infinity really is. Imagine that you're the hotel manager of a hotel named Hotel Infinity, and the hotel has infinitely many rooms. But then, a new guest walks into the hotel and needs a room. But there is a problem. Every room at the hotel is booked with infinitely many people. You might be thinking, you're just gonna have to turn them away. But actually, you can still fit the new guest. How? Well, I'll show you. The guest in room 1 moves to room 2. The guest in room 2 moves to room 3. The guest in room 3 moves to room 4, and so on. And what this does, is it frees up the one room for the new guest to perfectly go in. Here's where it starts to get really crazy. Imagine that not 1 trillion, but an infinite line of new people show up and they all need a room. Do you think that you can still fit them in the hotel? I'll give you just a little bit of time to think about it. The answer is, yes, you can still fit them all in. Here's how it works. You tell each guest to move down double their room. The guest in room 1 moves to room 2. The guest in room 2 moves to room 4. The guest in room 4 moves to room 8, and so on. Infinity plus infinity equals infinity. This frees up an infinite amount of rooms for the new guests. Imagine that you look out the window, and everyone is happy, but then you see an infinitely long bus pulls up with an infinite amount of people, and there's an infinite amount of buses. You're probably wondering, is there a way to fit them in? The answer is, yes, you can. Now, unfortunately, I don't know how to actually say it properly. You might want to look it up on YouTube. All I know is that infinity times infinity is still infinity. But did you know that there are actually 2 types of infinity? Here they are. That's right, there's uncountable and countable. Let me tell you about countable. Countable infinity is the infinity of counting numbers, like 1 trillion, and tree 3, and fish number 7. Even though these numbers go on forever, they're still countable. Uncountable infinity, however, is so gigantically more enormous than countable infinity, and it is also so big that there is literally no way to count even from 0 to 1 in a finite amount of time. Even if you had an infinite amount of time, you still wouldn't be able to get there. Another thing that proves an uncountable infinity is larger is a thing called Cantor's diagonal argument. You see, Georg Cantor, a mathematician, proved that if you were to list every real number diagonally, you would have already used up every single natural number. This means that the set of real numbers is larger than the set of counting numbers. And there's even proof that infinities are bigger than others. But, anyways, I hope that this video was helpful, and make sure to stay tuned for more mathematical content like this. Bye, and have a great day.